here's example 5 with getting the equation of a trig function from the graph. So if you want to follow along with this, with all these examples here, you can click the link in the video description and you can open up a worksheet there, print out the worksheet and follow along if you like. Okay, so for example 5, we're just going to do the same thing we did for the first 4 examples. We're going to follow these steps here. Okay, so again, if you want to know about these steps in more detail and some of the reasons behind some of them, check out example 1, check out the video for that, and then come back here if you'd like. So for example 5, let's just go through these steps here. So step 1, find the vertical shift b, if any. So remember, b is the max value plus the min value divided by 2. So that's max y value plus the min y value divided by 2. So if we look at the graph here, it's kind of hard to see, but there's a negative sign right there. Okay, we're below the x-axis, so all the y-coordinates are negative. So the max value is -1/2. It happens here, and it happens here. That's y-coordinate -1/2 happens here and here. Y-coordinate of -3/2 is the min. Okay, it's the smallest y-coordinate on the graph, happens here and here, and a bunch of other points as well. Because remember, for trig functions like this, sine and cosine, it just keeps going infinitely far to the right and to the left. But anyway, so b equals max value, -1/2, plus the min value, -3/2, all divided by 2. Okay, so really what that means is -1/2 minus 3/2, so that's -4/2, all divided by 2. -4/2 is -2, -2 divided by 2 is -1. Okay, so b equals -1, so there's a vertical shift. That's going to complicate things a little bit, just a little bit. So anyway, that's it for step 1, find the vertical shift b, if any. So step 2, determine whether to use sine or cosine. So since we have a vertical shift, it's going to be a little more complicated, this step now. So just like we said in example 3, the other one with the vertical shift, what we're going to say now is 0, 0 has moved, so to speak, to 0, -1. Okay, what are we talking about? So since we have this b equals -1, that means there's a vertical shift. Okay, so we're using one of these guys here, this guy or this guy, and this plus b out here, that represents a vertical shift. So since b is -1, that means we have a vertical shift 1 unit down. Okay, so everything got pushed down 1 unit. Okay, and you can kind of see that from the graph here, everything pushed down below the x-axis 1 unit there. Okay, so now what that's going to affect is the question we ask ourselves. So let's zoom out a little bit. So remember, to do this part here, step 2, if there's no vertical shift, then we ask ourselves, does the graph go through 0, 0? Let's zoom out a little bit more. Does the graph go through 0, 0, or does it not go through 0, 0? If the graph goes through 0, 0, then it's a sine graph. If the graph does not go through 0, 0, it's a cosine graph. Now, since we have a vertical shift here of -1, then instead of 0, 0, we're going to ask about 0, -1. Okay, so what we want to ask ourselves is, does the graph go through 0, -1? Okay. Okay, so again, normally with no vertical shift, we would ask ourselves, does it go through 0, 0? Zoom out a little bit here. Okay, so again, with no vertical shift or anything like that, we ask, does it go through 0, 0? If yes, it's a sine function. If no, it's a cosine, because cosine does not go through 0, 0. But there's a vertical shift. Everything goes down 1 unit. So instead of 0, 0, we're considering things pushed down a unit. So sine of x minus 1 goes through 0, -1. Cosine of x minus 1 does not go through 0, -1. Okay, does not go through 0, -1. So we look at our graph and we ask ourselves, does this go through 0, -1? So let's zoom in here. Okay, so we see, okay, this, where is 0, -1? Well, here's 0, x equals 0 is on the y-axis. Here's -1/2, something that's not labeled, -3/2. So we see each little tick mark represents a unit of a half, right? So -1/2, -2/2, which is actually -1. Okay, -1. Okay. Then -3/2, -4/2, which is -2, -5/2, so on and so forth, right? Doesn't matter though. But the point is this is -1 here. So this point is 0, -1. Okay. So again, -1/2, -3/2. So each tick represents a unit of a half. So -1/2, -2/2. if you want to be a little more precise about it, you could say, okay, remember we talked about this in one of the other examples also. B is actually the average of the max and the min, right? If you add the max and the min together, divide by 2, you're taking the average. So B sort of represents the y value that's halfway in between the max and the min. Okay, so B gives you the y value halfway in between. So here's the max, here's the min, halfway in between is right here. So halfway in between, the y value is B. Well, B I already know is -1, okay? So halfway in between this y value here, it must be -1. Okay, so again, B is like an average of the max and the min because it's halfway in between the max and the min. Okay, the y value is halfway in between those max and min values there. Okay, so anyway, here's 0, -1. So the answer to our question, okay, does the graph go through 0, -1? Yeah, totally. Okay, yeah, the graph does go through 0, -1. So because it does, the answer is, since the answer to the question is yes, what does that mean? Do we use sine or do we use cosine? Okay, remember, we're not doing 0, 0, we're doing 0, -1, but the answer is yes. The graph does go through the point of interest. Okay, normally with no vertical shift, the point of interest is 0, 0. You know, does the graph go through 0, 0 or not? But again, we have a vertical shift of -1, so our point of interest has moved, so to speak, to 0, -1. Okay, so yes, the graph does go through the point of interest. Yes, if the graph does go through, okay, the graph does go through the point of interest, so it's a sine function. Okay, so we're going to use sine. Okay, so yeah, so it's a sine. Oops, let's zoom in a little bit on that. Yeah, so it's a sine. So then y equals a sine omega x and then plus b. Okay, yeah, we already know what b is, but we're going to save that for step 5. Substitute a, b, and omega into the equation from step 2. So step 2 is determine whether to use sine or cosine. So from what we just talked about, we just found out that it's a sine function because the graph does go through this point of interest here. Okay, since the graph does go through there, you know, the point where 0, 0 has moved to, the graph does go through there, so it's a sine function. So we're going to use this in our answer here. Okay. Okay, so the answer is going to have this form here, a sine omega x plus b. We already know what b is. That's great. We'll hold on to it till the end. Now, what's next? That's it for step 2. Step 3, find the amplitude absolute value of a and use it to determine a. So absolute value of a is max minus min divided by 2. So absolute value of a is the max value, which we already know is -1/2, minus the min value, which we already know is -3/2. Okay, we talked about that when we did b, all divided by 2. Okay, so max value, min value, -1/2, -3/2, and here we're subtracting them. So -1/2 minus -3/2, that's really -1/2 plus 3/2. So -1/2 plus 3/2 is 2/2, and that's all being divided by 2. So 2/2 is 1, divided by 2 is 1/2. So the absolute value of a is 1/2, so what that means is that a itself has to be positive 1/2 or a has to be -1/2, because these are the only two numbers that satisfy this here, that the absolute value is 1/2, okay? These are the only two numbers with absolute value positive 1/2. Okay, so a is a half or -1/2. Now, which one is it? So this is where things kind of get a little tricky again because of the vertical shift. Vertical shift always ruining everything for us. So here, remember in some of the other ones, what we asked ourselves, we know we have a sine, right? So the question's actually a little bit simpler. For the sine function with no vertical shift, what do we ask ourselves? So we did that in an earlier example. I don't remember exactly which one it was, but in one of the earlier examples, we said, okay, sine function, does it increase through 0, 0, or does it decrease through 0, 0? So remember, if the sine function, zoom out a little bit here. If the graph increases through 0, 0, then it's positive sine of x, okay? Increases, it's positive, because that's just the plain old sine function right there. Now, if we slap on a minus sign, that's going to flip it upside down. So if we flip this upside down, that increase becomes a decrease, and it's going to look like this. So if we have a negative sign out front, remember that flips it upside down, and then it's going to decrease through 0, 0. Okay, but again, we have a vertical shift here. Okay, we have vertical shift, so 0, 0 has moved, so to speak, to 0, -1. So our point of interest is 0, -1. So then what we ask ourselves, is does the graph increase through 0, -1 or decrease through 0, -1? So if we look at the graph here, let's just zoom in. So if we look at the graph here, we see, well, here, as we move from left to right, right around there, the graph is actually decreasing through 0, -1. Okay, the graph is decreasing there. So since the graph is decreasing there, that means A has to be negative. Okay, because remember that decreasing, if you decrease through your point, if you decrease through the point of interest, you have to have a minus sign out in front. Okay. So let's see. The graph decreases through our point of interest, decreases through 0, -1. So now that by itself only tells us that A has to be negative. Okay, and again, the reason is because if you decrease through your point of interest, you have to have a minus out in front here, right? You got to have that minus sign out there. So this just by itself only tells us that A has to be negative, but we already know that A is either this guy or this guy. So if A has to be one of these two guys, and this tells us A must be negative, then the only thing A can be is this, okay? So A equals -1/2. Okay, so again, we know A is one of these two guys from this algebra that we did here, and we also know since the graph decreases through the point of interest, that means A must be negative. So if A is one of these two guys and A is negative, then A has to be -1/2, okay? So that's it for step 3. Again, usually one of the more complicated steps, and the vertical shift doesn't really help us there. It makes things a little more complicated. So anyway, step 4, find omega from the period. And remember, the period is capital T, which in general is 2 pi over absolute value of omega. But again, for these types of problems, we can just take omega to be positive. Why is that? Because if omega is negative, then we can just use even property of cosine or the odd property of sine to simplify and take omega to be positive. And then we have to worry about reflections over the y-axis, things like that. It gets a little more complicated, but also we don't really have to worry about negative omega. First of all, because of that reason, with the even odd properties, combined with the fact that we already did, we already worried about positive and negative with A. Okay, we already worried about that there. Okay, so those two things sort of together sort of tell us that it's okay to take omega to be positive. All right, anyway, so now step 4, we find omega from the period. So what we have to do is look at the graph and find out what the period is. Okay, so zoom back in here. So there's no phase shift, so it's nice to start at 0. So if we start at 0, we're right here. And if we want to follow along, so 0, if we follow along the graph here, where are we going to be back here? So right around here, right at 4 pi over 3. Okay, so once we hit 4 pi over 3, we see that the graph is going to start repeating again, right? So we see that here it starts following along that same pattern again. So right at 4 pi over 3 is when we start repeating. So the distance from here, from 0 to 4 pi over 3, that means t equals 4 pi over 3. Okay. So remember, t represents the period, and since it takes 4 pi over 3 units to cover one complete cycle, okay, after 4 pi over 3 units we start repeating again. So t, the length of one cycle, is 4 pi over 3. Okay? So we'll come over here, we'll zoom out a little bit, and we say t equals 4 pi over 3. Okay? But also remember, in general, for these types of problems, t is 2 pi over omega. So t is 2 pi over omega. Okay, so both of these guys equal t, so they have to equal each other. So in other words, these two things together imply that 4 pi over 3 equals 2 pi over omega. Okay, so multiply both sides by omega. Okay, and then let's also divide both sides by 4 pi. Okay, so we can get rid of this over here, and then let's also multiply both sides by 3. Okay, so is that the slickest way to do it? No. I mean, we can do it all in one step, but whatever. So 3 here. Then here, the omegas cancel. The pi's cancel. 2 goes into 4 twice. Okay, so what's left over? Kind of a big old mess. So what we have now is just omega by itself on the left. That's great. That's wonderful. And then what we have over here is just 3 halves. Yeah, 3 halves. Okay, we had that 3 on top from multiplying both sides by 3, and then the 2 on the bottom from canceling the 2 and the 4. So omega is 3 halves. Okay, so that's step 4, find omega from the period. Now step 5, substitute a, b, and omega into the equation from step 2. So the equation from step 2 is this guy right here, right? So that's our equation from step 2, and we know we found b equals -1. Okay, remember that's here b equals blah 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 equals -1. That's what we have there. We found out a is -1/2, and we just found omega is 3/2. So once we slap that all together, kind of at a room here, oh, there's some space down here. Okay, so then y equals -1/2. Okay, so a is -1/2. Sine, it's a sine function. Omega is 3/2. Okay, so omega x, 3/2 x, plus b. B is -1, so plus -1 means -1. And that's it. So that's it for example 5. A little more complicated just because we have that vertical shift. The vertical shift really does sort of complicate things a little bit. So that's it for example 5 with determining the equation of a trig function given the graph.